Looking at exercise 3.9, so when you try to solve a quadratic equation, obviously it's a tower of 2, you can either factorize it, you can complete the square if you're asked, or if you can't factorize a quadratic equation, then often you'll resort to using the quadratic formula. And here is the quadratic formula, which you did see last year in Year 10. So for any quadratic equation, ax squared plus bx plus c equals 0. You know, a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. And of course, a can't equal 0 because you would not have a quadratic function then. B can be 0 and so can c, but a can't be 0 because you would not have an x squared term and it wouldn't be quadratic then. So here is the formula for to solve the quadratic equation. X is negative b plus or minus the square root of b squared minus 4ac over 2a. We're going to prove that actually by completing the square on ax squared plus bx plus c equals 0. So we're going to prove that this is the quadratic equation by completing the square. So we're going to start with ax squared plus bx plus c equals 0. Do we ever complete the square on ax squared or only on an x squared? Only on an x squared. Now, because it's an equation at equals 0, I could divide through by a, which is what I'm going to do. So, or I can take a out as a common factor, but I think I will divide through by a. And I'm allowed to do that because it's an equation. So I get x squared plus what? b on ax plus c on a equals 0. Now remember, when I want to complete the square, don't I just like to keep on the left hand side the x squared term and the x term, and I take the constant term over to the right hand side? Now c on a is a constant because there's no x in it. What's the next step of completing the square? Don't I halve the coefficient of the x? So what is a half of b over a? b over 2a. Alright? And if you're ever not sure what to do there, you just write it out like that. That a half, I'm supposed to halve the b on 2a. So you go a half of b on a. Multiply the numerators, multiply the denominators, is b on 2a. So the reason I do this, don't I add b over 2a squared to both sides? So I add b over 2a. So I'm doing half the coefficient of the x. So this was half the coefficient of the x. That's what I was working out there. Now, how do I write the left-hand side? Why do I write it in this format? Because I've got x plus what? How do I write this as a perfect square? X plus b on 2a squared equals negative c on a plus, we should expand this other one. What do we get? b squared over 4a. What do you think? 4a squared, you're right. What do you think I should do now on that right-hand side? Two fractions, adding, the denominators aren't the same. What should I do? Make a? What are we trying to come up with? b squared minus 4ac. If you make a common denominator, won't I be multiplying this fraction by 4a over 4a? There's your 4ac. So I'm going to make a common denominator, and I'll multiply this fraction by 4a on 4a, which is minus 4ac plus b squared over 4a squared. So I've made a common denominator. Multiplying, now why don't I just write that on my next line as b squared minus 4ac. Can you see? And so now if I've got something squared equals this, what's my next step? Isn't it to square root? So x plus b on 2a equals plus or minus the square root of all of this. Now I'm going to write the minus 4ac plus b squared backwards. b squared minus 4ac over 4a squared. Are we okay? The left-hand side squared is that. So left-hand side is plus or minus the square root of the right-hand side. Right. We're nearly done. X plus b on 2a equals plus or minus. Now, you can't square root the numerator, so it's b squared minus 4ac. But if you square root 4a squared, what do you get? 2a. Now I'll bring the left-hand side b on 2a over. So I've got minus b over 2a plus or minus the square root of b squared minus 4ac over 2a. Are those denominators the same? So write it with a single denominator. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. Now that's the quadratic formula. Reason we do it, and we practice doing this, it's actually good practice in you completing a harder complete the square with algebraic terms. Alright? Using quadratic formula to solve. So why would we use the quadratic formula here? Let's just put everything over to the left-hand side. Y squared minus 3y plus 1 is 0. You look at it and you say, I cannot find two numbers that multiply to give 1 and add up to give negative 3. You've got two choices, complete the square or quadratic formula. Of course you'll go quadratic formula unless you were asked otherwise. So y, it's not x equals because y is in place of x. Y equals negative b plus or minus the square root of b squared minus 4ac over 2a. So it's negative. And look, some people like to write on the side that a is 1, b is negative 3, c is 1. Alright, so it's negative negative 3 plus or minus the square root of, now negative 3 squared is 9, minus 4 times a is 1, c is 1, over 2 times 1. So it's 3 plus or minus the square root of, isn't it 9 minus 4? It's the square root of 5 over 2. So if you had to give this answer to three significant figures, you've got two answers, 3 plus root 5 over 2 or 3 minus root 5 over 2. Root 5, how big is root 5? Bigger than root 4? A bit bigger than 2. This answer should be about 2.5, bit bigger than 2.5. Anyone? What did you get? 2 point? Alright, what did you have before that? 2.6. So 2.618, etc. To three significant figures is three figures. 1, 2, 3, it's 2.62. And the other one, 3 minus root 5, should still be positive, this answer, because root 9 is 3, root 5 is just a bit bigger than 2. Or this one should be about, etc. 196, etc., which is 0.382 to three significant figures. Now, so three significant figures, 1, 2, 3. This 0 at the beginning of 0.382 is not significant. Zeros at the beginning of a decimal are not significant. However, zeros at the end are. Indicates degree of accuracy, that you can measure that accurate. Just this one, leave your answer in surd form. Just trying to come up with one where we'll have some cancelling. 2x squared plus 1 is 7x. I'd be bringing the 7x over, but in the middle. So minus 7x plus 1 equals 0. Don't put it on the end because you're going to mess up your A, B, C, perhaps, maybe. Right, you've got to minimize errors. A is 2, B is negative 7, and C is 1. So you can just go ahead and do that. X is negative B. I always write out the formula. Plus or minus the square root of B squared minus, plus or minus the square root of B squared minus 4AC over 2A. And substitute. Plus or minus the square root of negative 7 squared minus 4 times 2 times 1 over 2 times 2, which is 7, plus or minus the square root of 49 minus 8. What's that? Square root of 41 over 4. Now, nothing, square root of 41 can't be simplified. This one cannot be simplified, but I believe this next one can. Just the last example. I think this one has simplification at the end. So H is, I'm just going to write it straight out. Negative B is negative 12 plus or minus the square root of 12 squared minus 4 times 1 over 2 times 4. So it's A is 4, B is 12, C is 1. So you can work that out. Negative B plus or minus the square root of, this is 144 minus 16, which is that 128? I think it's 128 over 8. Someone check. Yep. Now, we know that 4 definitely goes into 128. I don't know if 16 will. It does, actually. Oh, no, I don't know. 4, that would be 2 root, what's 4 into that? It's 32, yeah. Oh, but you know what? 16 goes into 32, so 64, I think, goes into, oh, of course, 64. 64. It's 64. Negative 12 plus or minus the square root of 64 times 2 over 8, yes? So it's negative 12 plus or minus 8 root 2 over 8. Now be careful, you can't divide through by 8. You can divide through by 4. You can pull out 4 as a common factor if you want, or each of those is divisible by 4. It's the same as factorising out the 4 on the numerator. Do you want me to factorise out the 4, or can we just divide each of those whole numbers by 4? So we get negative 3 plus or minus 2 root 2 over 2. Just the whole number bits, okay?